Okay. Main task was always the analysis of vegetation data. Now, both Helen and Meinrad are retired, but retirement does not mean that there is no work to do. And today we will actually hear about the work that they have done during the last few years. And it's on Vegedots. And Vegedots is a program for the analysis of vegetation data. So the thing that they both have done during their whole work life. Vegedots is a vegetation analysis program, and it's actually still widely used in Switzerland for research, but also teaching, and also for practice. So consultancies and the cantons use Vegedots. And today we will hear about the new version of Vegedots and what is possible with this new version. And I'm really looking forward to your talk now. Please.
So, good morning, everybody. I will give first a short overview about our talk. And so I will make first an introduction to the Vegedots. Then Meinrad will show how to import and clean the vegetation data. Then we make some examples, exploring data, basic analysis, and also some examples with R. Since we do that simultaneously with our program, I switch now to the Vegedots. So that's the table editor of the Vegedots. And most of you know probably here in the columns we have one vegetation record. And here in the upper part we have the header data, and in the lower part the species data. So the Vegedots is sort of a table which gives assistance for this vegetation data. And there are some helpful functions. For instance, I show you now the input of the data. So if I want to make here a header for the year, then I would choose, or I could choose the data type. And the data type I can choose here. So I would choose integer. And that means it only accepts integer numbers. So if I make an input of a wrong, if I make a mistake, then it would tell me that's invalid. Now I just saw what I not made yet. It's now the new version is available in different languages. So since the talk is English, I switch now the language, and you see these languages are available. That means the menu is translated, the underpoints also. I switch now to the English. And the new version has also a good documentation for help. That's also in German and in English. So, and the species data has also helpful assistance, since Vegedots is connected to a database with the species names and the whole taxonomy structure. It has, so for instance, if I give in Andromeda polyfolia, as you know, for instance, in the FLORAP, it only needs an abbreviation and then it completes the name. So if you really have to input the data, it's very helpful not to make mistakes. So Anthoxanthum odoratum, for instance. Here it's not clear, but then the botanist has to know what he means. Does he mean the species or the aggregate? Here I want to put the species. And the shortest abbreviation, maybe you can guess what it is. Botanists should know. JJ is one species. Some people know, I'm sure. It's Juncus Sciacchini. That's always the test whether the connection works to the database. And here is the cover for the species, for the column. And the cover code is also different in different data. So you can choose the cover code you need. Here, I would like Brown-Blanquet code. And if I put the right one, then it's okay. But if I put, for instance, a 6, which is not accepted, then it would say it's invalid. So that's helpful assistance for the input, but also afterwards for controlling if you get data. Now I take a demo data set, and that's this demo. Okay, now that's a table, how it normally is. We have 12 columns. That means we have 12 vegetation records. Each column is a record which has the cover code for the species which really occurs in one plot. So we can have a list of a plot. That's the species that occur in that plot. So here the table is already a little bit larger, but not that large, of course. 12 columns, that's not that much. It might have hundreds or even thousands in our project. And then there is a nice function where you have the overview about your data. So you can choose a category and make a summary of that category. And then I see I have 6 plots for fens and 6 plots for bogs. So if I had no entry in one column, I would also find. So I like this function because of the overview, but also to find mistakes. And then what we have behind all the information of that taxonomy structure. So I would like to know, for instance, Dactylorhiza maialis, how is the situation now? Does it have synonyms or how is it? I can ask here, you see, we have this menu with many options, and we cannot show you all things, but the basic data has the information about this structure for synonyms, for instance. So I ask for the Dactylorhiza maialis, and it tells me Dactylorhiza maialis is the accepted one. And the other names are old names, which are now in the checklist of the Swiss Flora Now synonyms. Another species I want to show is this Orchis maculata. If I ask here for the synonyms, then it tells me that my name here, Orchis maculata, is not the accepted one. So it was used before, now it's Dactylorhiza maculata. So another good function for the data checking is cleaning the data. So if I get this data, then I can clean my data. That means I can insert the valid names. And then the program goes through all the names, and it would stop with Orchis maculata, since this is only a synonym and not the accepted one. And I can tell, yes, replace it by the accepted name. Okay, so another good thing is to count species number. That's very easy to do. Species occurrences, I can count, for instance, here the entries per column. I could also count the cover. The cover mean it would implement the cover code, but here it's only an entry which is counted. Then I have here now the number of species. I have it here already, always implemented here. You see that's the count of each column. But another question might be, and that's very helpful also if you want to know how many mosses you have in each plot. So you have to first select the mosses, and since there is this information behind whether a species is a tree or shrub or moss, you can first select the bryophytes and then count for that. And I do that now. Now here, rows of species, I select the species. And you see here you have many other criteria you can choose. For instance, it might be interesting for you how many red list species you have. Then it would select that one, or your certain indicator values, high moisture value or so, or certain families. You are an orchid specialist and you would like to know how many orchids. I want now the growth form. That means I would choose the mosses. And here I have now selected all the mosses, and then I can count again the entries of the selected species. And these are now the entries of the bryophytes. I should now that right, of course, that so. There might be another question. There are many questions, of course, in vegetation data, but maybe it's interesting to know which species are really typical for a certain category. Which species in my data set are typical for fens and which are typical for bogs. And this is called the table of characteristic species, which you can produce. And there are different indices, which are measurements for this typicalness of the species. The category I want to have is the unity, fens or bogs. Here are the formulas for these coefficients that you know what it really computes. And here I have now this table. So we see here, okay, fens are in the upper half, and the Schwärzia perennis is the most typical one in my data set for fens, since it occurred 4 times in fens and not even once in bogs. And so it goes down and the coefficient decreases, and so we have these ranks. If I scroll down, I come to the other unity, to the bogs, and here we see the Polytrichum strictum is the most characteristic one for bogs in my data set. So that's a very helpful. Polytrichum strictum occurred 6 times in bogs and not even once in fens. There are others. Calluna vulgaris also is quite typical for bogs, but it occurred once in fens. That's why the coefficient got a little bit less. You could also make other analyses. For instance, if you do it for botanists, which botanists found which species? And so we do not do that here. So Meinrad will now continue with the important cleaning of the data.
Yes, my task is to show that these functions are not only useful, they are necessary to evaluate data. I make a new file to import a data set which is stored in this Excel. That's an original data set. I only changed the names of the botanists. Otherwise, it's original. I show what it is. We have header data, and to the right, there are the species scores. species and scores. Also the other way around than we saw it in Vegedots. Control copy. And I go back to the program, file, import, transposed from the clipboard. That's what I have now. Here, the header data, here, the species. The program recognized that it is a species because it looked up in the database and found something like this. The first thing I always do is to see if it recognized really the species. It did not. The program did not. Acer pseudoplatanus is also a species. I take those species and with Control X and Control V, I put them to the species. Why did it not recognize? Do somebody see that? There is a point here. Acer point, or the dot, pseudoplatanus. That's not a species name. So I have to replace those points by a blank. I replace all, and now we can, as Helen said, we can check the data. Now it asks if it should replace Acer pseudoplatanus with Acer pseudoplatanus linea. No, I don't want the other names. So I set up the check. I say I don't want other names because the species list is, was heißt eindeutig? Is not ambiguous even if you have no authors. If I check now, it asks Achemilla millefolium, it's aggregate. Which aggregate is it? I think it might be this. Aconitum altissimum, it doesn't know. I looked up what it is. It's Neomontanum. But that you have to look up yourself if the species list doesn't know the species. Agrostis confer schraderiana. Confer needs a dot. Yes. Yes. Etc. So you have to check the species. And I go a little bit further to show you other examples. Yes. And this taxon is not known. Why is it not known? Everybody knows Euphorbia cyparissias. If you look really here, it's not correctly written. And so on. Another example is here. Why doesn't it know? That's dangerous. Here, subspecies is marked with SSP. We don't replace it because I can look up here what Helianthemum nummularium exists. We have really a subspecies nummularium. Was it grandiflorum? Aha, gut. Grandiflorum. Yeah. You can also make mistakes with my program. So you would have to check all the species. I don't do it now, we have not time for that. Now we check the cover codes. I have the cursor in the cover code section. Why is it invalid? We have chosen brown blanc. This is not brown blanc, it is %. Now it accepts it, but there is a 0. We use to say if a species doesn't occur, it's empty like this. And 0, what means that? I suppose it might be. I would have to ask the botanist what they meant with the 0. I think they did forget to note the cover code in the field. But so I prefer to replace the zeros by not a variable. Only the zeros which are only the whole words. We had 4 zeros, which are now replaced with NA. Ungültige. Not, should tell him to accept the NAs. Perhaps we don't want that. Allow NA for covers. That's not a valid cover code either. I think you would have to decide if you put here NA or if you accept that unsure cover estimation. I accept it now. Now the data are okay. Now let's look at the header data. We have sites. We have 6 different sites which are regularly distributed. Helen will tell about it later. We have plots, 6 recordings per plot. We have a date. That's not the date. I would prefer to have a year because the month was always the same. So I split this row by this. Why do you have troubles? It's by this digit. So I don't need the 7. I delete it, and that's the year. What years do we have? 30 records per year. That seems reasonable. Surface that what is, yes, a manipulation type. It was an experiment. So 36 plots, there are release per manipulation type. That's okay. Then we have coordinates. I transformed them for further analysis, but now we have no time. Then we have an observer. There is, that was a mistake. In the original data too, I had the idea to show you this type of mistake. We have three observers, but one, that's the same, so we have to replace the B1. We don't ignore the case. The other one. Now, that seems to be reasonable. What do we have else? I think now the data would be prepared for analysis. And I pass the word to Helen.
So I go ahead with now with the cleaned but the same data set. To have an overview, I will now I mark now X and Y and the management type, and we can make such scatter plots where we get good overviews about the data. So again, we see we have 6 sites. On each site, one management type is implemented, and 6 years, each year they were revisited. So that's the experiment was set to find out whether different management types influence the vegetation. So it might be that the species number would develop in a certain direction. So I will count the species first. Occurrence species. That's the species number now. Okay, I have it already, species number. And to see how was the development over the 6 years, I will make now a calculation. I will count the mean for the species number for each year. And I will do that with this function here. You see there are many other functions, parameters available you can compute. I will do now an arithmetic mean and do that for certain groups for the year. I can choose number of species I want to evaluate and the year as the group, and I get this table. That's the mean of the species number for each year. And if we have a fast look at it, 44, 47, 49, 51, it could be that the species number increased over time. A nicer visualization would be a box plot. And there are some functions which are not directly, can be computed in Vegedots, but in the statistic program R. And I switch now to R, so I can choose this calculating machine. And here we have all these things available. You can only provide the data and then make your own functions in R. There are different possibilities for graphs, regression models, tests, ordinations, and so on. I will choose now the box plot for groups for the year. So my values are the number of species, and I want it for a year, the box plot. And if once the Vegedots is connected with R, and this is here done already, then you need only a short command to run this function that you choose before. So I get the box plots of these values. As we assumed before, the species number increases over time. That's what we see here in the data. It might be interesting to test whether this is significant. And there are some tests also available. I want to test now each year with each other year. So always 2 groups I want to test. Here are the tests, and I will make paired samples. Since the plots were revisited, these are always pairs, and the tests are more sensitive, of course. So paired samples, my data is number of species, the time points is the year, and RS plot is the ID of the number, of the plot where the records were made. And here we have this table. And where is my R plot? Here. So, for instance, here what we see that first to second year, yes, it's significant different. Here is the test, and the significant ones show me that there is a difference between these groups. Since we have now here 6 years, it's more adequate to make another test, a repeated measure test, because it's over time. And this test, again, I can do in R. And so here are tests. I make it's in here repeated measures, all values in one row. My element ID is plot, time points is the year, and the number of species here. And again, I can run the function in R. And then I have the output of these repeated measure tests, where we see that time is really, there's differences which are significant. The time is significant different, and there is a linear trend which is significant. What we saw in the box plots, it increases, and also the elements are significantly different. So, of course, the experiment was also done to see whether the different management types had a different influence, not only over time, all plots. So I will now, I want not miss something. Okay, now we have seen that this increasement of the number of species, but there might be also an effect of the observers. Since the observers learned over time, maybe they found more species, and the botanists were not equally involved over time. That might have also an observer effect. And so there are other indicators which are more robust than species numbers. And these are the indicator values which are more robust to analyze the vegetation data. And for that, also Vegedots is very practical. We can compute the mean indicator values for each plot. Most of you know, but there is also a big database for each species in Switzerland with all the parameters of the flora indicativa, and they are connected to the species. So I will choose now some indicator values, and I compute the arithmetic mean, and this I have now here. I could do the same analysis before, repeated measures and so on, but I will do now another one and look at the different developments of the different management types. So I compute now the mean value for not only for the year, for each year, but also for year and management type. I will do that, analyze each row. I do that here, the arithmetic mean, but stratified, not only for the year. Here are the values, the data to evaluate, but not only the year as before, but also the management type in the group. And then I get this table. So I have now the mean value for 2010 for abandoned plots, all the abandoned plots. And here, that's rather a big table, so we don't have an overview about that. I can now save that again in Vegedots. I do that. In this table. And I open this table of these results. So that's what we had in the table before. And if I want to have at the end a line diagram, so I see the development of over time of the different management types. That's why I need an X and the Y axis, and for the X I will have the years. That's why I want this category in 2 rows. I take again this function and I split the header data. I divide by the separator underline. So I have now the category of the year and the category of the management type. And the year is now such a special data type of integer number. I choose this. This is not a text variable integer. And since I wanted the year in the x-axis, I take it and put it before. And now we look whether that works. I have the category doesn't mean when it's here, but the year and the light value. I will now look. Yes, it works. I have now this line diagram of the 5 management types over time. How was the light value in the development? And here we can go back to the experiment and see whether it's really plausible what we see here, whether it's clear. And it seems that all management types, it decreases a little bit, the value. Only in the blue one, it stays constant. And it seems, it makes sense because this management type means scrapping in autumn and mowing, so it's quite a bit input. And there are others like the abandoned ones where when you don't make anything, the vegetation gets denser. But if you do the right management, you can keep it open. So that's quite a nice visualization. Yes, then you can continue. Also du gehst ja nochmal zum anderen, oder? Schienige Platte, so. So.
Ja.
Ja.
One important thing for the botanist is to classify those recordings. What vegetation type is it? Here we have this function, and first I have to go back to in Switzerland, actually we use this book. In this book we have lists of characteristic species for each vegetation type. For instance, for open box, Andromeda polifolia, etc. Eriophorum vaginatum, as all botanists know. Now, this book is in this file. First, I show perhaps this file. That's a vegetation type, and there is a list of characteristic species for this vegetation type. Potamion, yeah, it's an open water vegetation type. That's the list which Delars in his book showed. Or this lemnion, there are many lemna. And so on, there are, that's the list of. And now to attribute the recordings to one of these lists, we can determine them. A common algorithm to attribute is the intersection divided per the union. That means the Jacker index. That means it counts the species which occur in the relevé and also occur in the lists of this book, and divided per the sum of the species of both sets. And we can also make the most probable attribution, or if I choose two, also the second probable attribution. And we want to see the Latin name of the vegetation type and also the German name. That's the determination of what do we have in this data set. We have mainly Caricium ferruginea and some Poium alpine and a few Seslerion according to this algorithm. If you take another one, for instance, let's take another one, another algorithm. This what's Typothea, also the Typothea. We work with Typothea. That's we have an app. There's an app which you can, in the field on your phone, you can attribute a vegetation relevé to a type, and that's the same. We take this algorithm, and we have, now I want to compare if we have the same attribution for both algorithms. What did I take? The German, not the Latin one. Yeah, so I take here the Latin name too. And if I compare like this, I see there are differences. And I see also that there are units where there is no Latin name, so I will take now to make a table to be able to compare easier. I make a contingency table, but now for the German names, because they are complete, I compare the German name of the Jacquard attribution with the German name of the Typothea attribution. And I get now a table that's often quite useful to have such a table where I see the Caricetum ferruginea was attributed by the, which was attributed by the Jacquard, not always was attributed to the same unit by the Typocea, sometimes it was Bergfettweide. So I can compare easily classifications, even if they are not, if they have not the same names. The categories are different, have different names. You can compare them anyway. That's what I wanted to show. There are many other functions, but we have not the time to show them all. Now, are there questions first in the people which are here? For our team.
Questions?
Yeah, here from Zoom they are asking, is this software is used only for Swiss flora, or it could be used for other floras after inserting its database?
I am right now, my work is to make a species list for Europe, also to take over a species list for Europe. It will be possible in a month. It would be also possible to have species lists not only for plants. I worked with species lists already for dragonflies, for instance. It's possible with all organisms.
Any other questions? I have one. If you do the species list of Europe, then maybe you could also implement the indicator values, the new ones for the flora of Europe.
Yes, but I have only 3 indicator values yet,
Okay.
or 4. So
Right.
it's, we need the data. If the data are present, we can do it quite easily, but the work is to have the data.
Yep.
So it might just be my lack of understanding of the history of the database. And so the idea is that this database now includes some number of reveillés or some amount of data from Switzerland, and that it's flexible so that people can now add new data to the database. Is this the goal, that it continues to grow, or just maybe a little more history of how it's used?
Ich habe es nicht verstanden.
Okay, if I understood your question. So the database which is behind is the species list of Switzerland and the whole taxonomy structure, all the indicator values, that's behind. But if you put now data, your data, you can put every data and compare it and clean it with, that's what's behind. What's that your question?
But then is the data collected?
Yeah, you have, for instance, this data we showed here, that was collected, that was collected somewhere in Switzerland, and we got it, and we had to analyze it. You have to have the data to analyze it.
But then you've made this beautiful, cleaned it.
Yeah.
Got metadata, etc. Now to archive it, but eventually you have an archive of all these.
Oh, it depends. Here, it's the purpose to make now a report about this. That was, and then this analysis will flow into this report, and maybe it's archived where the people were there. But here at the house, we are in this big monitoring project involved, where we have this data from all over Switzerland about how many plots, Klaus? I say
30,000.
12,000, but
Oh,
they
man.
are revisited. Now we revisited most of them already, and that's a big work to keep this database in order. That's Tobias. The database of the data and the database we talked about are available for everybody, the indicator values and the species structure.
Question somewhere.
My question concerns the database. Is it possible for the user to exchange the database, to use other species lists, other databases?
It will again be possible in 2 weeks. In the old version, it is possible. In the new, it will be again in 2 weeks.
Any other questions? Oh, okay.
How does this software allow reproducible analysis? Does it generate a script describing the steps followed by users? Does this software generate a script describing the steps followed by the user so that another user can repeat it?
Not yet, and it has not the first priority. First should do the things with the species lists and so. But let's say in a year, there will be a possibility to record the steps you do.
Okay. So, no other questions? No? So I guess the program is online available for free, correct?
Mm-hmm.
And it's a Mac and PC version, or is it only PC?
In some time, there will be also a version for Mac, but now we have only for PC.
Okay, but there's the plan to have it also
No,
for Mac.
in summer, I think I will try to
Okay.
compile it on Mac.
Good. Okay, so if there are no
Perhaps
others,
we can point to there will be a course to learn this program, to exercise, make exercises, and in the end of March. There are some places available still if you want to sign up.
and signing up is simply sending an email to you. Okay, good. Okay, so thank you once again for your talk and enjoy your lunch.